Hey, my name's Avery, and in this video we're going to be looking at integrals with composite functions and how to solve them using U substitution. So in all of these problems we're going to follow the same process. Starting with number 1, our problem says we're finding the integral of x cubed times x to the 4th plus 16, where that is raised to the 6th power. And so your first step is always going to be to determine a u. Which would be like kind of the base if you were looking at it as a composite function. So in this case, my u is going to be x to the 4th plus 16, and then you would just find the derivative of that, which is called du, and in this case, the derivative is 4x to the 3rd times dx. So you're going to go back and kind of start piecing the problem back together. So you had u to the 6th times du. We had to do something special in this case because if we look at our du, it's 4x to the 3rd. But if we were to solve this problem like normal and then use this 4x to the 3rd, then our numbers would be off because, as you can see, there's no 4 outside of our u right there. So we're just multiplying by 1/4 so that it can all be even if you were to go back through and undo your work, basically. So you have 1/4 times this, which is where you're finding the antiderivative of what's inside the integral sign. So 1/4 times u to the 7th over 7 plus c. And then all you're going to do is go in and plug in your original u where you had u as a variable right there. So you've got 1/4 times x to the 4th plus 16 raised to the 7th over 7 plus c. And then I just combined those denominators right there. So you have x to the 4th plus 16 raised to the 7th all over 28 plus c as your final answer. So for number 2, we've got a trig problem, but it's going to be the same kind of process. We're finding the integral of secant squared 10x dx. And so same thing, you would find your u, which is 10x in this case, and then your du is 10 times dx. And then what I did is find that dx equals du over 10 or 1 over 10 times du. Because we're going to use that same process and bring that 1/10 out to the front. So again, you just have your 1/10 and then finding the integral of secant squared of u times du. The derivative of secant squared would be tangent, or the antiderivative, plus c. And so then you just plug in your u down here, and that gives you your final answer. You've got 1/10 tangent of 10x plus c. For our final problem, we've got one that's using e. And so, as you can see, we're trying to find the integral of e raised to 6x cubed minus 6x plus 2 times 9x squared minus 3. In this case, our u is whatever e is being raised to, so 6x cubed minus 6x plus 2, and then the derivative of that is 18x squared minus 6. Now, if you'll notice, this isn't a direct one like we had over here where it's like 4 and 1/4, but our du is double of this value right here, meaning we're going to have to multiply everything by 1/2 in order for it to all equal the same thing. So that's exactly what I did, bring down the 1/2, and then same thing as before, you've got e to the u times du. Just brought it down. The derivative of e to the u is e to the u, and then just bring down your plus c, and then plug in your u for your equation you had up here. So you've got 1/2 times e to the 6x cubed minus 6x plus 2 plus c, and then I just brought down that 2 into the denominator, but that is your final answer.